We're now ready to begin the second half of our systems of equations problems here, looking at the actual real-world applications of solving systems of equations. The whole purpose of systems of equations is really not to find where the lines intersect, but more importantly, to solve for 2, 3, 4, or 5 unknown items. So with systems of equations, you can have any number of variables. The key to it is if you have 2 unknown things you don't know, you'll need 2 equations. If you have 3 unknown variables, you'll need 3 equations. If you have 5 unknown variables, you'll need 5 equations. So let's look at this problem and see if we can get a basic handle on it. We have a dietitian who needs to mix 10 gallons of milk. That's 2.5% milk fat for that day's rounds to the patient. So we need to end up with 2.5% milk. He's got some milk that's 4% milk fat. He's got some that's 1.5% milk fat. And he wants to know how much of each should he use to end up with his 10 gallons of 2.5%. And you're probably going, oh no, it's a percent mixture problem. I thought we were done with those. Well, it is, but it isn't. Last time we did percent mixtures, you just were you had some certain amount, you were adding one thing to it, and the question was how much should you add of that one thing? Now we have 2 unknowns. So yes, it's similar, but not the same. I do want to take you back to 4th, 5th, 6th grade math and ask you how you find a percent of something. So if, for example, you want 5% of the number 32, how do you take 5% of something? Yes. You take 0.05 of translates to multiply always. So you're taking 5% of 32. If you multiply 5 times 32, you're going to get 160. But I have to move my decimal point. So it's actually 2 places, so it must be 1.6. Okay, I know that was really basic, but I got to make sure we remember how to find the percent of something. Kind of crucial here. Okay, in this case, what are the 2 things that you don't know? This is really, really, really important. You must define what your variables represent. People always skip this step and then they confuse themselves in their own problem because they don't know what they're trying to find. What is it we don't know? It says how much of each kind of milk should we use? So, okay, I got 2 different kinds of milk. So X is the gallons of the 4% milk, and the Y can be the gallons of 1.5% milk. I'm going to change that to a decimal, make it easier to work with. Okay, right there, if you define that, if X is the amount of gallons of each, how many gallons of milk are we making here? The dude wants to end up with 10 gallons of milk, so equation number 1 is just right in front of you. If X and Y are the 2 amounts you're going to use, don't they have to add up to be 10 gallons of milk? So the first equation is pretty simple. Okay, the second equation, you have to make your percentages balance. We got to get this 4% milk and this 1.5% milk to end up making us 2.5% milk. So this is why I just did 5th grade math over there. All right. How much milk fat am I going to have when I do the 4%? Well, I've got 4% milk, and I have to take it times the number of gallons I'm going to make of 4%, which is X. That's 4% of X, plus I got the 1.5% of Y. Okay, and here's where it's different. What percentage of milk fat am I trying to end up with? I'm trying to end up with 2.5%, so I'm going to end up with 2.5% of how much? What's my total amount of milk? It's not X plus Y, if that's actually true, but I know the total amount of milk. It's 10 gallons, so I just need to take it times 10 gallons. Now, that's an ugly equation, won't lie to you. If I clean up here a little bit, I'm going to multiply out here on the other side of the equal sign. If I multiply that by 10, I will be at I'll get to move my decimal 1 place, and it will just be 0.25 now instead of 0.025. And, okay, I don't know how to do substitution or elimination with these variables. with these decimals. How would I get rid of all the decimals? Well, what's the largest number of decimal places I see? The Y one has 3 decimals on it. So therefore, if I want to get rid of all 3 decimals, technically, I'm multiplying this thing times 1,000. In reality, you could just go move it all by 3 decimal places. So if I move this first one by 3, that's actually going to give me 40x plus 15y, and it ends up equaling 250. If I bring down the other equation, x plus y equals 10, there's my actual system of equations. That's what I'm trying to solve. Okay, your pick, substitution or elimination. I'm sure I hear somebody out there saying substitution would be really easy here, and I agree. Substitution would be really easy here because I can so easily isolate x or y in that second equation. So, got a preference to whether we do x's or y's? I'm an old style algebra girl, so I'm going with y equals 10 minus x. What am I going to do with that? Yes, I'm going to take it and go put it in the y in the top equation. So I'm now going to have 40x plus 15 times, but in place of that I'm putting my 10 minus x, and that's got to equal 250. And so 40x distribute 15 would be 150 minus 15x equals 250. If I combine my like terms here, 40 minus 15 will leave me with 25x. If I subtract 150 to the other side, that leaves me with 100. And I'm left then solving with x coming out to be 4. Now the question is, what on earth does 4 mean? Well, look at what you defined x to be. We just found out that's 4 gallons of 4% milk. So there's one half of the answer, but I also need to know how many gallons of y am I using. Well, this one's such nice numbers, it doesn't require much, but technically I should come back over here to where y equals sub 4 in for x and discover that yes, my answer is going to be 6 gallons. But I know I had to make 10 gallons, so that was really obvious. So I'm going to end up with 4 gallons of 4% and 6 gallons of the 1.5% milk. And there is your solution. Okay, all very common sense oriented. You need to not make these, overthink these and make them too difficult. Okay, example number 2 here. We're going on a camping trip. Molly and Sam went rowing in their canoe. Took them 2 hours to row 4 miles upstream from the drop-in point. The drop-in point is where you can actually drop your canoe into the water and get started. Okay, so they went 2 hours going upstream for 4 miles. After a leisurely weekend, which is misspelled, of camping, fishing, and relaxation, they rowed back downstream to that same drop-in point, but it took them only 30 minutes to get back downstream. And it wants you to find 2 things. Find the speed of the current, and then find the speed of Molly and Sam if they were rowing in still water. So in fact, how fast are they rowing the boat, and then how fast is the current moving it? In the past, when we've done these type of problems, they gave you one of those. Now I'm not giving you either one of them. So, first things first, you need to set up what do my variables represent. Mission critical. What's going to be x, what's going to be y? Well, the 2 things they want to know are the speed of the current, so I'm going to make x be the current. And y is going to be their rowing speed in still water. So that's what we're defining our variables to be. Now, what little fact, once again, back from probably junior high math, did in Algebra 1, did in Algebra 2, did it this year. What's the relationship we need to know? We have hours happening here, we have miles happening here, and it wants to know speeds. What's the great equation we know that relate those three things? And I'm sure somebody out there is going, oh, of course. It is most definitely distance equals rate times time. So if you don't know that one, embed it forever. We've seen it before. Okay, so how am I going to come up with equations that relate x and y? Since I have two variables, I need two equations. Okay, well, I basically know two things. I know what happened when they went upstream. I know what happened when they went downstream. So I'm going to go with that situation here. And I know the distance they traveled. So if I go with their first equation, let's go upstream. I need their rate times time to equal their distance. I know the distance they went. Yeah, they went 4 miles upstream, told us that. So we know distance. I need their rate and their time. How fast are they moving? Do I know either one of those? Well, when they went upstream, I actually know it took them 2 hours. So I got their time. All I need is the good old tricky rate. How fast are they moving? Well, the speeds are all over here in our variables. The current's doing X, they're rowing at Y. Okay, if you're going upstream, what's going to happen to you? They're going to slow down. Their speed is slowing down by the current. So I know I need to subtract the two, but is it X minus Y or Y minus X? Well, they're going Y and they better be going faster than the current. So then the current is slowing them down, so you would be subtracting X. And yes, I need to clean up that equation, so that's really 2y minus 2x equals 4. Or I may decide I would prefer to have that negative 2x plus 2y if I want to reverse it. But let's do the second equation and see how that one turns out. Okay, equation number 2. Downstream. So now, how fast are they going when they go downstream? Well, after you've done this one, downstream ought to be pretty easy. Yes, their speed is y plus x this time. They're getting faster. Now, how much time did they spend going downstream? It told us they went down in just 30 minutes. So should I take this thing times 30? Well, that makes no sense because over here I did 2. That was 2 hours. This is 30 minutes. So yes, you need to deal with that and multiply by 1/2 because it's half an hour. And that's going to equal, they still went a distance of 4 miles. So if I distribute that one through, I have 1/2 y plus 1/2 x equals 4. And now that I have 2 equations, I can actually then solve the problem by substitution or elimination. Okay, I'm not real loving this fraction action here, so let's take this equation times 2 and make that a little cleaner, which will make that one plus y plus x equals 8. And the other one, when I put the 2 together here, then I'm going to actually have 2y minus 2x equals 4, and y plus x equals 8. Since on the last problem I did substitution, let's do this one by elimination. So do you want to eliminate x's or y's? Boy, I'd jump on that one. I would do my x's because they already have opposite signs. So I'm taking this one times 2 to make my x's eliminate. That's going to give me 2y minus 2x equals 4 and 2y plus 2x equals 16. If I add them together, I've got 4y equals 20. And of course then y equals 5. Have I answered the question? Of course not, because I haven't solved for the other variable. Which equation is easiest to go back to here? Well, by far, y plus x equals 8. So now I would know that 5 plus x must equal 8, which means x equals 3. Now, you need to write your final answer in a form somebody understands. So what do those numbers mean? Well, that's another reason why we defined up here what does x represent and what does y represent. X is the speed of the current. So yes, I've just discovered the speed of the current is 3, and we were doing miles an hour, so 3 miles per hour. And how fast were they rowing? Well, we all ended up with an answer of 5, so they were moving their canoe at 5 miles per hour. And there you have your solutions. It's just a little bit unique look at, not that hard to do, but something a little bit different. Okay, finally, a couple other little examples. Fixed costs and variable costs. This is a common problem if you have any intention of thinking about being a business major, and particularly your second level accounting course, you're going to see these all over the place. They love fixed costs and variable costs. Okay, when you're talking about how much, this is usually in production or manufacturing things, but with any business, every business has fixed costs. Fixed costs are those costs they have to pay every month or every week, regardless of how much they make, whatever business they're doing. But this is the things you have to pay for. Your rent, your utilities, basic things that your insurance that you have to buy. Doesn't matter how much you produce, you're going to pay these things out. So common examples here are rent and insurance, stuff like that. It's the basic costs. They're unchanging. You pay it regularly as planned. Okay, your variable costs are the costs that vary with how much you produced. So it's the cost you're spending to actually produce your items. Okay, so we're going to do a little pretend problem here. We're not going to completely set it up, but we're going to get a start. Okay, cost per item. You're making yo-yos. And suppose we know we spend 20 cents per yo-yo for the plastic. The actual plastic pieces to put together. What else do yo-yos need in order to work? Of course, they got to have the string. So we know that the string is costing us 6 cents for each yo-yo. We're spending 6 cents on that hopefully high quality string that won't wind up so bad. And then you're not just going to sell it as a loose yo-yo, you've got to package it. So you actually also have your costs for packaging. And say we are spending, you have to have the cardboard, you got to have the plastic over it. We're spending 11 cents for packaging per yo-yo. We're also going to pretend here that our fixed costs that we're paying, in this case, this is say per month, we're spending $1,200 in fixed costs by the time we do our utilities, our insurance, all the things we have to pay for. So how do I turn that into an equation for my cost? Well, we know that cost, then the fixed costs are flat $1,200. They are not changing. Plus, how much are we spending per yo-yo? Well, if you add up all those individual costs, looks to me like we are spending 37 cents per yo-yo total. And so if we make 100 yo-yos, it's 100 times 37 cents. If we make 1,000 yo-yos, it's 1,000 times 37 cents. So we would write that as 37 cents X. That would be a cost equation with fixed and variable costs. Okay, they're also then going to give you a revenue equation. Revenue is the amount of money you receive from sales. It has nothing taken out of it. So in our little pretend situation here, we need to figure out, okay, how much are we making per yo-yo? What do you want to sell your yo-yos for? Okay. Say we are we're selling our yo-yos for $3.50 each. That's what our yo-yos cost. That's what we're selling them for in the store. So our revenue equation then is simply $3.50 times the number we sell. Okay, they're going to ask you to find what they call the break-even point. So a break-even is where you haven't lost money and you haven't gained money. It's every business wants to know it's a break-even point because that's the point you do start making money. So it's basically, where do my revenues equal my costs? And if I want to know where revenue equals costs, I'm looking for where do these two lines intersect. So if they want you to find the break-even point, you have to find where these lines intersect, which means do substitution, do elimination, or graph it on your calculator and intersect it. That's what's happening here. It's going to be the same thing we just did, but you're going to solve that situation. You had to set it up as a real world situation. Okay, last but not least, I want to do a calculator problem, and I've already got that built for you. I hope, somewhere maybe in government, you have talked about some economics somewhere along the way, and hopefully you know that as there's what's called supply and demand. In this particular example, if you pop back over there a second, we've done a study on this new model smartphone that's out. They've studied it over a month's time or 10 days, I don't remember what it was. When they charged a price of $214.20, the demand for them was $8,125. There was $15,250 in supply. Okay. When they dropped the price to $171, demand was higher, so therefore supply was less. When I dropped it really low price, $129.60, then the demand was really high, but that dropped the supply down substantially. So you can see what's happening here. They want to find the point of what they call the point of equilibrium. Where are supply and demand equal? Because that's what you want to manufacture. If you're the owner and you're manufacturing this stuff, you don't want to make too many that you can't sell. And you don't want to make too few and mis-selling them and making some more money. So you want to know this point of equilibrium. So supply and demand equations are always, your supply usually starts, you've got a lot in supply and it drops down as you sell them over time. Demand increases, hopefully, more people want your stuff. And guess where the equilibrium point is? You got it. Where the two of them intersect. Now, what's evil and mean though is they're not giving you the equations. They're giving you the data. This data is actually in your book and can be found on page 515. There's the tables there for this particular situation. Our problem is that we have all this data. This goes from about 10 days. Yeah, it was 10 days they did it. We've got all this data. How do I turn that data into equations of lines? Well, yes, we know how to take data and turn it into lines. It's called regression. So we're going to take this data, which I just made disappear off the face of the earth. It's up there somewhere. We're going to take this data and we're going to turn it into an equation of the line for demand, an equation of a line for supply. So of course, how do we do regressions? Yep, we got to add a page. We're going to add a data and statistics page because I want to do this by graphing. Okay, the price is the thing. The price, as the price varied, the demand changed and the supply changed. So your price is your common factor between them. So I'm going to plot the price. In this case, I'm going to do demand. Okay, that's what's happening to demand. It's actually dropping off some here. As the price increases, it makes sense. As your price is getting bigger, as your price goes to the right, your demand is dropping down. Okay, we need an equation of a line to fit that. So yes, we are just going to run a basic menu, analyze, regression, get a good old linear, and get that equation. Now here's the downside. We need to take that equation into a graph in a few moments. And I could not find any way to copy and paste this in there that was not a mess. So you will need to write down the equation, unfortunately. so that you can transfer it into a graph page later. I have already done that on here. So there's my equation for demand. I'm going to do the exact same thing. I'm going to add a page, add statistics. I'm going to graph price this time. But now I want to get a supply equation. So this also makes sense. As my price gets bigger, what's going to happen to my supply? Well, as the price gets higher, people don't want to buy as much, so your supply gets bigger. So my supply is increasing with that. I'm going to go get a menu, analyze, regression, another linear. You'll need to write that equation down as well. Because since I want the equilibrium point, I need to know where this supply and demand equation equal each other. Now, in order to do that, I need to intersect. And you can't intersect on a data and statistics page. So here's where you have to go add another page. I've actually created that page, I hope. Thought I had. Maybe I hadn't. Okay, maybe I didn't do that. Yes, I did do that. I'm not insane. I've done that. Don't know why it wasn't going there for me, but okay. I've done the page. I'm going to hit tab here and show you. I have the equations in F2 and F1 so that you can see those equations. I've already put them in there. And I've already hit enter. They're check marked. Notice they've got check marks. They should be graphing. Why don't I see these equations? Well, hopefully after this many years, you're going, it's the viewing window. We can't see it through the window. So yes, we got to change the window settings. Zoom out will not work. If you look at this table of data, and notice these values, your prices were in hundreds, your demand and supply were in 10, somewhere between single digit thousands and up to perhaps even 20,000. So this thing, you got to have your X coordinates for price running in hundreds, between 100 and 200 something, and then you're looking at 15,000, 17,000 on the Y's. Zooming will not work when these are that far apart. So I'm going to go to menu here, except I got to get back to my page. I'm going to go menu. Yes, you guessed it. Window settings. My X maxes, my supplies, there's a little bit over 200, so I'm going to go 300 as a high. Don't really care if that minimum's fine. Same way my Y's, where there was at least a 17,000, I think 20,000 is high enough. So we're going to try with 20,000 here. Hit OK, and hey, wow, look, it's our equations. Woo! Oh dear, that was not good. Trying to get a hold of the equation, not the line, so I can get this out of your way. Okay, it's being a pain. All right, there, finally, I got them out of the way. So now I can go find my equilibrium point. Gosh, do I know how to find an equilibrium point? I think so. Menu, analyze graph, intersection. I'm going to get over here on the left, click, highlight across my intersection point like always, and there it is. Press enter. Okay, problem is you need both numbers, and as always, it's not showing you it went to scientific notation. I have found a solution to that. Okay, you can do the old way we've been doing it by going to attributes and changing the attributes to more digits. But I believe I have found, and if you can get it to stick is the problem, but for right now I certainly can. If you go to menu when you're on a graph page, you have to be on the graph page, you will notice there's a settings number 9 here. That's the settings for graph pages only. And you'll notice when we get here, look, it's different. Graphs and geometry settings. Okay, display digits, I'm going to set it on automatic, so that it'll do automatically however many it needs to do based on the number it calculated. I'm going to hit make default so that sticks. I'm going to tell it, yeah, okay. And now look, it's displaying the needed number of digits. Now, what does this mean? 160.988, rounded off probably about 161. Okay, you have to remember what we were graphing. We were graphing price and then the quantity and supply and demand. How many phones were we actually going to sell? So this is telling me I would have 161, roughly $161 is what I should be charging, or $160.99. And my demand would be around 12,233 phones. So I know what to charge, that's optimum, that's gonna be my break even, and I know I have to have at least 12,233 in supply to meet the demand that's gonna happen. Okay, manufacturers like to know that, they don't wanna manufacture too much or too little, so now they know, okay, break even is 12,233. Hopefully they're gonna manufacture more than that because they think they can sell more than that. But that is going to be that equilibrium point where supply meets demand. And so that's extremely valuable information for the business world. All right, enjoy.